All right. Next, I want to show you how you can easily take your videos, annotate them with Labelbox, and then get your video annotations into Databricks so you can start to do advanced AI with video content. In this example project, I've got a couple of recordings of a rocket ship launch, and you'll notice that I have very simple annotations on here. I'm labeling where the rocket ship is. I'm also labeling the phase of the rocket launch, describing the animation that the rocket is going through, and annotating which camera I am using to look at the rocket. Now, I'm not a rocket expert, so these launch sequences and animations, they're just made up, but I'm using these to show you how these annotations can map to specific frames and how bounding boxes are expressed in the export from Labelbox. So this rocket is going to go through a couple of different phases of launch. You'll see the ignition turns on. The bounding box is moving very smoothly with that rocket and animating with it. Along the way, the launch sequences are changing. The animation classifications are changing. And so every frame is a little bit different, especially with this moving bounding box. There's a different coordinate for that bounding box on every single frame. And so what I want to do is get all this information into Databricks so that I can have those annotations on a frame by frame basis and use that to train my machine learning model. So when I'm in Databricks, all I have to do is call LabelSpark get annotations and provide the project ID for my video project. The first thing that I will receive is an index of all of the videos in my project with some metadata about those videos, like who submitted the label for those videos, what is the name of the MP4 file that I annotated, and I get a link back to those videos, as well as this column here for the labels. Now you'll notice a difference between how we express image labels versus video labels when we use the get annotations command is in video, we actually return an address where you can get the frames for each video. So this initial call won't include all of your labels. You have to make a second API call to this address to get those frame annotations. So we could do that very easily. We actually take care of that for you. So what we want to do is pass this bronze table here through to our get video frame annotations command. So I'm just going to run that. And now the Labelbox connector for Databricks is communicating with Labelbox, visiting each of these addresses and pulling in frame by frame annotations for all of the videos in our project. So this could actually take quite a while in some cases. If you have dozens of videos of 30 seconds to a minute, even longer. In this case, we only have 2 videos and they're relatively short, so it only took about 15 seconds. But now I have this video data frames object, which is just an array of Spark data frames, and each Spark data frame includes the frame by frame annotations for each video. So all I have to do to process these data frames into a flattened bronze and then ultimately a silver table is to call those same methods that I used for images, but to do it iteratively through my video data frames array, so that I'm producing these arrays of flattened bronze tables and silver tables for each video in my array of videos. So I'm just going to run that. And to save time, I've already displayed the frame by frame information for the first first video here in video data frames. So you'll see that this label column looks very similar to what we've seen before for annotations for images. You get the list of all the classifications for that frame, as well as the coordinates of the objects in that frame. And you'll also notice that in these labels here, we also have some information about the frame number. There we go. So if I just search on frame number, there's the 5th frame, the 6th frame, 7th frame, and so on. And as you can see, these each correspond to the number of the data row. So this is pretty handy, and we can store this in our data lake. But the bronze and silver table methods that we include with the connector library can refine this a little bit further, so it's a little easier to work with. So I'm just going to show you what this looks like if I have my flattened bronze table and I join my row on the data row ID from the original bronze table list up here. This will allow me to get the data row ID attached to every single annotation. So I'm just going to run that. And so we have the data row ID for that specific video. You'll notice they're all identical. It's because they correspond to the same video, as well as that familiar flattened table where I get my list of all of the different responses for classifications. I get the list of all of my object coordinates in that frame and this handy frame number column right here. So if I filter this down a little bit further into a silver table, I can get some analytics on what's in the frame. So I get my frame number as well as the classification split into its own column here. So I just have the launch sequence, as well as a count for all the objects in each frame. And you'll notice this is a pretty boring data set because every single frame for the first couple hundred frames is about the same. But if I keep going, you'll notice each frame changes. There's a different phase of the launch sequence. The shuttle count does not change because there's only one shuttle that we're recording. And this is how you can handle large amounts of video data with Labelbox and use the Labelbox connector on Databricks to get all the annotations for each frame back into your data lake.